In this video, I'm going to walk through the process that you follow if you want to use large language models such as OpenAI to process your own data. And this is a very common use case because although the OpenAI and ChatGPT use cases are very well known and very powerful, they are limited in terms of what they can do with the data. For example, there is a cutoff with the data. So typically, if you want to process your own data, you need to provide that information to ChatGPT in order to have it analyze and answer the questions that you have. So first off, before we do that, let me just go ahead and kind of show you the problem that we're trying to solve. So here I've got a couple documents that we're going to use for testing. One is I've got the text for the Declaration of Independence, and I've got the Constitution. As you can kind of see, these are both PDFs, and the data for the Constitution is pretty large. There's 19 pages of data here. And if I wanted to use ChatGPT, let's say, to process this and maybe answer questions related to this document, you might expect to be able to maybe do a cut and paste of this data. But as you'll see, if I go ahead and just copy this to the clipboard and come into ChatGPT and just say, let's see what this is again, we'll just answer a question, how use the document below. What are the rules to be president? And I'll go ahead and paste the document in there. So I've pasted the entire Constitution in there, and it should be able to answer that question. So you'll see though, if I run this, you'll see that I get a message here. The message you submitted was too long. Please reload the conversation and submit something shorter. That is because there's a limitation to how much data that you can send to ChatGPT. So something like this is not doable. So we need to find a different way of doing this. And it turns out that there is a whole host of different tooling out there that allow us to do that fairly easily. But we have to do a few things. So what we're going to do here in the video is kind of walk through the steps to be able to accomplish what we want. That is, use our own PDF, our own data, to take what we need, pass it to the large language model, and answer questions based on what's in that document. But before we can do that, we need to process the data and kind of set it up so that it can be used by the large language model. So this diagram kind of depicts the process that we're going to follow. So here, it's actually two different pieces to this. On the one hand, what we have to do is we have to take our data, in this case a PDF file, and we need to extract the actual text from it. And we have to then split that into what we call chunks. And all of this is necessary in order for us to be able to break that document down into small pieces that can then be sent over into the engine to process it. So on this left-hand side here, that's kind of what we're talking about is when you want to process your own data, you need to extract the data out. You need to split it into manageable chunks. And then you need to also take a step further and create embeddings. And I'll talk more about what embeddings are as we get closer. But in a nutshell, embeddings are just ways for us to take the text and turn it into something that can then be used by the large language model. And in our case, we're going to build something called a semantic index, and then we're going to basically store that into what is called a knowledge base. And or for the lack of better words, this is simply going to be a database that we're going to take all of our data and put it into, that we can then pull back the details when we need to. And so this indexing process is something you'll do one time with your data and just fill up this database. And there's plenty of options out there in order to do that, and we'll walk through how that's done. Now, once we have that semantic index created and it's all stored for us, here is where we can leverage our ChatGPT style questions, where we can ask the questions that we want about the document. What we're going to do though is we're going to do a couple things with it. Well, first off, we need to go into that same knowledge base that we created, and we need to pull out just the relevant pieces of the document. We can't send the entire document, so we're really just going to be looking for the ones that are relevant to the question that we're asking. And so we can use semantic searching to be able to pull out just the relevant pieces. So we're essentially, instead of passing a 19-page document, we might be getting 2 or 3 paragraphs of the document that are relevant to the question that is being asked. So we're then going to take that, and what's going to happen is that we're going to get back essentially a list of the results that match our question, or potentially have the answers to the questions that we're asking. We're then going to take that along with our original question and send that to our large language model like ChatGPT. And from there, we will get our answer. So essentially, we will be kind of marrying back our data versus also the power of something like OpenAI or another large language model that we want to use, and be able to get the answer from our document. Okay, so that's the process we're going to follow, and we're going to go through and show you how you can do that with a few simple tools, all for the most part free, except for the cost of perhaps the large language model itself. If you're using OpenAI, there's a fee obviously for that. Everything else is free. Okay, so let's walk through that. So here I have my Juniper notebook that has the steps we're going to follow. And first off the bat, what we need to do is we need to talk about a few of the tools that we're going to use. So the first thing is we're going to use a tool called faiss, which essentially is a Facebook's AI similarity search tool. Essentially, it's a library. We're going to use this as a way of storing our data. So if you go back to our diagram, it's going to essentially be this portion here. So we're going to be using that tool to handle both the semantic index and also the semantic searching, and that's what we're going to be using for that. Okay, so that's free. It is something that you can download. There are other ones out there. You can use Pinecone is another one, but essentially think of this as just going to be our database that we're going to be using to do that initial search. Okay, so that's the one thing we're going to have. We also need to have OpenAI. So you'll need to make sure you have an OpenAI account, and you'll need to, this is the one thing you'll have to pay for. So there is a small fee for you to make API calls. You'll need to log in, sign up for an OpenAI account, and you'll need to get access to that account. Don't worry, it's really very inexpensive. I have mine set for $10 a month, and I never go anywhere near that, near it, depending on what I'm doing. Most of these queries are very cheap, maybe a couple pennies for some of these searches. So it's very easy to use and test. But it is the best model out there, showing you the power of how to do this. There are other, obviously, free ones out there, and I plan on having another video to show some of the other options with that. But we're going to stick with OpenAI just because we want to show some more of the power here. So once you do that, you will need to log in and create an API key. This API key is what we're going to be using to make our calls. So essentially, this is how when you want to make an API call to the OpenAI engine, you will need to provide this key along with the other calls that you're making. So this is essentially how that they know who's making the calls. So they know who's to charge. All right, so we're going to have that. And then finally, we're going to use something called LangChain. And so LangChain is another tool that allows us to build applications on top of LLMs, and very powerful. So it's a framework for developing applications powered by language models. So we can build these applications. There's a lot of different tooling around there, and we're going to kind of show you some of that today. But it does allow us to be able to do things such as embed, create these embeddings for the OpenAI model, create what we need to make the calls, and essentially assemble everything so we can send it to the LLM models when we're ready to make those initial calls. Okay, so LangChain is very, very popular. So we'll need that library. That's free. So all of this is free except for the since you need to have an OpenAI account to get that access key. All right. So we're going to install a few required packages here. We need to have obviously LangChain, we have to have OpenAI, and we need to have the faiss that we talked about. And there's a couple other ones that we're going to also use. Unstructured is, so that is a Python library or set of libraries that allow us to be able to read unstructured data and process it. So this is how we're going to be this is what we're going to be using to be able to load our PDF files and read them. Okay, if you have other file types, you can do the same thing. Okay, so this essentially will allow us to read different file types. So you need to have that. Just also real quick, I'll just mention. So part of what we're going to do is we're going to be loading up our documents. In this case, our tests are going to be PDF documents. But as you can see, looking at the LangChain documentation and using something like unstructured, you can load all sorts of different types of files. So there are over 100 different loaders that you can use, and essentially you can pull the data out from any of these different file types and then use that and leverage that inside of your semantic database that we're going to be setting up. Okay, so you'll need to have that. And then tick token is also used to create the embeddings, and we'll talk more about what that means in a second. So that's what we're going to have to install. All right, I already have it installed here just to save time. So once you have that, you're going to want to also make sure you have some sample documents. I have 2 documents we're going to be testing with. I have the Constitution and the Declaration of Independence. Essentially, I'm just going to pull those down, and I'm going to store those so that you can get to them. So I have them sitting here in my data folder. So you'll have those documents, and that's essentially what we're going to be loading up. You need to have an OpenAI key. So first thing is go ahead and put in your OpenAI key, and you can get that from the link here. Create one, and then go ahead and just copy that to the clipboard and paste it in. Essentially, that's going to be where we're going to be using this environment variable to store that. All right, so we're going to go ahead and load that. Now, the first thing we have to do is we need to load and split those documents. So here we're going to be doing this portion. We're going to load the documents. We're then going to split them into chunks. Okay, so that's kind of what we're doing here with this first set. So we're using what is something called a directory loader, and that is a LangChain method, if you will, that will allow us to be able to, actually I guess it's a class. You'll be able to load up a directory. Here I'm passing in my content directory here, and I'm saying go load all the files in. Okay, so as it's loading, it's going to be using that unstructured library that you saw above, and it's going to be figuring out what file type it is, and based on that calling the appropriate dependencies to pull those libraries and pull the text out of those different files. All right, so that's what's going on. So we're going to load those up, and we're going to load up basically, in our case, 2 documents. So after I run this, you'll see that I've got this new 2. So here are my 2 documents that are sitting here. Right now, it's just loaded. I haven't done anything yet, simply just loaded them up so I can then process them. So here is where we're actually going to split the documents. So we're going to use the recursive character text splitter. Now there are many different types of splitters out there, and you can read up on the ins and outs of which are the best. But in a nutshell, what this is going to do, when you split the document, you have to kind of make a couple decisions. All right. What we're going to do here is we're going to decide how we want this to be split up. How big do we want these chunks to be? Okay, and that's important, right? Because you want to make sure that you have these text chunks be large enough so that they have the context in order to answer the questions, but they can't be too large that they overwhelm the LLM. Remember, there's a limit to how much you can pass to your large language model. And eventually these text chunks are going to be passed to the large language model. So we have to kind of pick a number here that kind of makes the most sense. Now I've seen numbers of 500 or 1,000, and you can vary that and try different values to see what works best for your data. But essentially that's kind of what we're doing here is we're chunking that document into certain text sizes. And then we also need to specify a certain number of overlap. And what's going on there is that we want to make sure that these texts that we send to the models have all the full context. So sometimes they're going to split, but they may not split directly on a sentence per se, right? It's going to be based on so many characters. So we want to make sure that if we split in the middle of something, that we don't lose the context. And that's why having an overlap of 20 allows us to be able to say, look, we're not going to completely just chunk everything. We are going to have these chunks are going to have some of the characters from a previous chunk, right? So there's going to be a little bit of an overlap so that we have a better chance of having our context directly or correctly identified within our specific chunks of data. Okay. So you kind of see here, I'm going to run the text splitter, and then I'm going to run this. And you'll see just from these two documents here, I split it into 187 individual chunks. So to kind of demonstrate this, let me go ahead and paste in here. So I'm going to paste in 3 print statements of 3 chunks from the document to kind of show you the overlap here. So here I've got 3 different chunks, and if I scroll, you'll kind of see this one, for example, starts with Connecticut 5, New York 6. And if I were to scroll over, you'll see that that got the same thing here. So I've got some additional characters here. So there's some overlap. So part of this was in this first chunk, chunk 4, but it's also in chunk 5. Okay, so essentially by splitting and using this overlap, you are kind of keeping certain sentences together, or at least trying to have a better opportunity to get your context the way you need it to be. Okay. Once we have it split, the next step is to go ahead and create the embeddings. And so real quickly, kind of just try to describe what an embedding is. So a text embedding is kind of like a code that represents words and sentences or even whole documents in a way that computers can understand. So it's a way to convert the text of something into numbers so that the computers and the algorithms can work with the numbers more easily. So how does it work? So think of it this way. So imagine you wanted to describe colors to somebody who could only understand numbers. You could say red is 1, blue is 2, and green is 3, and so on. These numbers represent the colors. Similarly, in text embeddings, word or pieces of text are turned into numbers that represent their meaning. So let's say we had words of, like, for example, cat, dog, and fish. A text embedding might turn them into numbers like 0.2, negative 0.3, or 0.5. Okay, so the idea here is that text embeddings help us understand similarities between words. And it would make sense that the difference between, for example, cat and dog, maybe the difference if you did a math computation on it, those numbers would be smaller, meaning that they're more similar. That's kind of the way to think of it, that these text embeddings can help us with understanding these similarities. So if the numbers for cat and dog are close, it means the words are similar in meaning, which would make sense again because they're both pets. All right, so that's kind of what we're doing here. So in our case, we're taking our embedding, that what we're going to send, our text, and we're going to send it through an embedding, and it's going to pop a set of numbers here like you see here. Okay, so what I'm showing you here is what a sample embedding looks like for the OpenAI model. So here we're using the OpenAI embeddings, and we're using the model text embedding Ada02, which is the one that's more popular at the time of this recording. So given this model and given this text string, okay, what we're going to get is we're going to get back a list of numbers. All right, I'm showing you here the first 8 of that string, but again, if I wanted to, I could do the entire list, but that would just kind of clutter the screen a little bit. So I'm just kind of showing you this is what it kind of looks like. These are all just numeric values, and they are semantic, and they kind of represent the string in a way that can be embedded and understood by the algorithms. All right. It's important to note also that they have a certain length to them. So you'll notice that the text embedding Ada02, if you looked at any one of them, they all have a uniform size of 1536. Okay, so depending on what embedding model you're using, you may get a completely different set of numeric values, right? So they're not something you can pass around without understanding what model created it, if you will. All right. So we're going to essentially take, this essentially is what's going to be stored along with our metadata for the documents in our vector database. We're going to be storing these numbers here, and we're going to be storing the text from our documents and our chunks, and it's kind of be passed together and stored in that document. So essentially we're going to take our text, and we're going to take the corresponding embedding for that text, and we're going to store both of them together and put them into this knowledge base, okay, and build this semantic index. And then what we can do is use the semantic search feature of the vector store in order to then pull out the matching embeddings and then the text that goes with it. So we're going to be using it in that way. Okay. So in a sense, essentially that's what we're doing here is we're essentially taking those embeddings, we're then creating these numbers, and then after that we will then store them in our vector store. Now what we're going to do is we're going to use our faiss data store. This is that Facebook AI similarity search library, okay, or database, if you will, that we're going to be using. All right, so that's what that's going to be. So we're going to then take the documents, so our documents that we split. So if we go back up here, so our documents that we split into 187 chunks, we're then going to take those documents and we are going to pass that along with our embedding model. And from that, we're going to get back our entire set of data that we're going to be searching against. So if I run this, it doesn't take very long. I have now taken all of our data chunks, created embeddings, and I have then put them into this faiss tool to create a search library. Once we have the search library, we can then, so actually let's take a step back here. At this point, we have done all this, right? So essentially these first steps are done just by what we just talked about. Now that we have our knowledge base set up, and essentially this document search, you can think of that as our knowledge base. Now that I have that search set up, I can now do what are called similarity searches against that vector store. All right. So the way that works is we're going to be using something called a similarity search that is part of what the vector store provides to us, is that similarity search. So essentially we're going to take a query, some question we're going to ask, and it's going to come back with the matching chunks that are similar to what I'm asking. Okay. So here's kind of how that would work. So if I ask the question, what is this document? And I pass that query, what's going to come back is I'm going to get the chunks of those documents that will tell me what these documents are, because that's what I'm asking. So it's able to determine that I'm asking about the document. These are the matching chunks from our vector store that can best answer that question. Okay, this is what we will be sending to our OpenAI model along with our question, and then we're going to let the OpenAI model give us back the answer based on what it sees. So remember, we couldn't send all of our entire constitution to the engine because it was too long, right? So now we have a way of just passing the relevant pieces of those documents that have our questions, and from that we can definitely send this. This is much smaller, and this won't have a problem being sent to the OpenAI model. Okay, so if I run that, I should get back my set of documents. So these are the documents that match that, and you can kind of see that this is actually a list. There's a document here. All right, there is probably another document starting here, and even another document here. So it sent me back a subset. Now the number of documents that come back, they are ranked. Okay, so you're getting back the most probable documents are going to answer your question, and you can control how many documents you want to send back. So I have it right here to default to 5, but I could change that number to be higher or lower. So again, these are other things that you need to be able to, you'll have to change, right? These are things you'll have to play with to figure out what works best. What size chunk works best. Maybe 1,000 works best, but with a 200 overlap, right? You have to make those decisions based on what your specific use case happens to be. Okay, maybe there's a different model that you want to use besides OpenAI's Ada 02, right? Another part of the equation is you'll need to figure out how that works based on your data. If you're not getting the results that you expect, then you need to change up something, right? Same thing with this number. If this number is too big, then that has the potential of being a problem, because then it may get to a point where, again, we're sending too much to the engine and we're back to where we were with having to send the entire document. It's just too large, right? So a large number may give us more chances of giving us the right answer, but it may get to be too large. So you have to play around with K5. Maybe 3 is a better number, right? And again, if you're using a larger chunk, then the number that you return will also need to be smaller, right? So that's where that whole, you kind of have to play around with those different numbers to see what works best. So now that I've got those documents, now what I can do is I can take these documents and I can then send them to the OpenAI or whatever embedding model or engine I'm using. So here I'm going to load in the chat model. And so this is OpenAI's chat model. We're using LangChain, which essentially sits on top of that and gives us a nice interface to be able to talk to these engines. So we have that. And essentially we also can provide the model. So I'm using GPT-4, but if you want to try 3.5 because it's a little less expensive, or even Text Embeddings 03 if you want to try a different model to see which works best for you, that's kind of where you can set that. So I'm going to go ahead and set up our access to our LLM. Essentially, that's going to be our connection back to OpenAI. And then what we can do with that is we can then take that and we can load it into something called a load QA chain. QA stands for question answer. So this is one of the pre-built chains that LangChain has put together for us. Again, that's really the power of LangChain, is it's given us all of these different sets of tools and functions and classes to be able to give us a really nice interface that sits on top of OpenAI or whatever engine you happen to want to use, and give us that nice interface. All right, so we're using the QA chain, which stands for question answer chain. We're going to ask a question and get back an answer. All right, so we're using that. And then we're going to use the chain stuff. So this is the part that is where you have to make a couple other decisions here, right? So I'm going to load up our chain, QA chain. I'm going to pass our model. So we're using the large language model of OpenAI, and I'm using this chain type equal to stuff. And all that simply means is basically take all of these documents that we returned from our vector store and just stuff them into the prompt and send it. And again, there are other ones out there. I will be providing additional videos to talk about some of these other chain types. But depending on what you're trying to do, you have to decide what type of chain type makes the most sense. In our case, just stuffing all the documents in is a simple one. But if you want to do one of the other ones, such as there's one out there where it'll re-rank them for you. That's another option that you can look at depending on what your use case is. All right, so essentially we're going to stuff all of our documents into the prompt. We're then going to send that same question or send the question to Congress. This is a question I'm asking: which branch of Congress has more members? So I should be able to answer that question. I'm going to send that to the OpenAI model. So essentially what it's going to do is, first thing it's going to do when this is called, it's going to call our get similar documents from vector store. So that's going to go up here and do our similarity search from the vector store, give us back the matching documents. I'm then going to take those matching documents. I'm going to pass them as input documents to the chain along with our question that we're asking. Okay, so I'm going to pass the question along with our matching documents, and then I'm going to get back an answer. In this case, I'm getting back the answer that the representatives has no more, House of Representatives has more members than Senate. And I can ask all sorts of different types of questions. For example, what are the rules of becoming president? And it would give me the matching documents. I then send that to the OpenAI model, and I get back a nice list here of the different rules. I can also query, for example, we had two documents. So this one I'm asking, who was the United States declaring independence from? And it was able to then go into that vector store, give me the matching chunks from the Declaration of Independence, pass that to the OpenAI model, and answer that question for me. Okay. Who was the first person to sign the Declaration of Independence? The first person was John Hancock. So it was able to read through the Declaration of Independence, go find who signed it, figure out what chunk had it, and then send that to the OpenAI model along with my question, and we got back our answer. And we can ask all sorts of different types of questions like that. Okay, so that's kind of how it works. You can definitely feel free to play around with this. I think it's very powerful, but as I mentioned, there are definitely going to be decisions that you need to make as you are deciding on how to fit this into your specific use case. Okay, and again, determining what model works best, what type of chain, how big to chunk the documents, how many documents to return. All of certain things are decisions that you need to make. One other thing I'll mention is that in this example, I'm showing you how to use the faiss store. However, you can easily change this to be something like Pinecone. There's a number of them out there. Pinecone's another one that's free. That's free for you to test out. It is a commercial site, but it is free for you to play around with and get used to, and you can kind of see that. But the advantage to something like Pinecone is that since it's a commercial offering, you're storing the data in an actual database, right? In our case, these documents will go away because they're not really storing it anywhere. And if I wanted to rerun this again later, I would have to redo the same process to recreate the vector store. But if you have something like Pinecone, you can simply reconnect to it, just like a database, right? Think of it as a database on a server somewhere. You give it the name of your server, if you will, and other information. You get back a pointer to it, and then you can just make queries against that vector store. So anyway, that's it. Hope you liked it. Hopefully, if you find value in this, please don't forget to like and subscribe. And if you have suggestions on other videos you would like me to do, please be sure to put those in the comments. Thanks very much.